In this video, we are going to do a visual explanation of the associative law of vector addition. That is, we're going to show why it is when you add three vectors, a, b, and c, it makes no difference if you first add a and b and then add c, or if you add b and c first and add that result to a. So let's start by drawing our three vectors a, b, and c. I'll draw them all in a tip-to-tail configuration like this. I'm also going to duplicate this diagram on the right side of the screen for later in the video. So looking at the left side of the screen, let's start with vectors a and b. They're in a tip-to-tail configuration, so I can easily add them using the triangle law of vector addition. That'll give us a resultant that looks like this, and I'll call it a plus b. Now let's take that vector a plus b and add vector c to it. Again, these vectors are tip-to-tail, so we can use the triangle law of vector addition to get a resultant that looks like this. Now since I started with vector a plus b and added vector c to it, I'll call this resultant a plus b in brackets plus c. Now let's move over to the right side of the screen. This time I'm going to start by adding vectors b and c. They are in a tip-to-tail configuration, so again using the triangle law of vector addition, I get a resultant that looks like this, and we'll call that b plus c. Now let's start with vector a and add our result of b plus c to it. Those vectors are tip-to-tail, so again using the triangle law of vector addition, we'll get a resultant that looks like this. Now since I started with vector a and then added b plus c, I'll call this vector a plus b plus c in brackets. Notice that that resultant is identical to the resultant when we first added a plus b. This will always happen, and we can conclude that it makes no difference whether you first add a plus b and then add c, or if you add b plus c first and add that result to vector a. And one question that might come up is, well, what if one of these vectors is the zero vector? Would that change things? Turns out it wouldn't. Remember, the zero vector has no magnitude and no direction, so adding it anywhere in this addition would make no difference. For example, say that vector b was the zero vector. In these brackets here, we'd get a plus the zero vector, which of course would give us vector a, to which we would add vector c. So the left side would be vector a plus c. On the right side, in the brackets, we'd have the zero vector plus c, which of course would give us vector c. So the right side would work out to a plus c as well. So having the zero vector in the mix makes no difference, and the associative law of vector addition would definitely still hold.